In any dataset, there are several different types of values or fields that you will find. You can broadly bucket them into categorical, numerical, and composite, and each has their own characteristics. Categorical allows you to do relatively fewer computations. You can list them, maybe you can sort them, but by and large, these are pieces of information that are there that you have to infer by themselves. For example, if you have colors like red, blue, and green, other than knowing that these are the colors, there isn't that much you can do with it. In comparison with numerical, where there are a series of operations that you can perform. These are numbers that could be real numbers, that could be integers, but you can add them, you can take ratios, you can multiply two columns and perform several derived operations out of these attributes. The third is composite, where you have even more operations that you can perform because composite typically comprises of multiple elements. For example, composites may contain an array that have a list of numerical values or a list of numerical and a list of categorical values. Let's look at the different types of categorical values there are. Boolean is one example, things that can be true or false, yes or a no, just one of two values indicating something that exists or doesn't exist. Or you could have unordered categories. Unordered categories are categories that are distinct and you can't sequence them in any way. For example, colors, red, blue, green. It's not like red is bigger than blue is bigger than green. Or cities. It's not like London is bigger than Paris or so on. However, there are other ways in which you can order them. For example, you can order cities by population. You can order cities by area. In these cases, we aren't really using the categorical value, that is the name of the city itself, to order. We are using another attribute, which is their population or their area. You could also sort them alphabetically, but then again, you're not treating them as individual categorical values. You're treating them as a sequence of letters and then ordering based on the letters and alphabets, A, B, C, D. They are in fact ordered. And that brings us to ordered categoricals, things like low, medium, high, the letters A, B, C. These are things that you can place in a sequence. Now, there are some sequences that are slightly different from just ordered. These are called cyclical sequences, and an example would be Monday, Tuesday, Wednesday, Thursday, the days of the week. And it's not like Monday is bigger than Tuesday is bigger than Wednesday, but you can order them in the sense that Monday comes before Tuesday, comes before Wednesday, and so on. And it's cyclical in that at the end it repeats. Similarly for January, February, March, etc. These two can be considered under ordered, but you could treat them as a different subsegment of ordered called cyclical. And then there is the unstructured categorical. These are similar to unordered, except that we just recognize that it's not a specific set of values that you can have. These are not enumeratable. You could have literally anything. So unlike the list of colors, which is a finite and known defined list of colors, or the list of months, which is a defined list of 12 months, text could contain anything. Binary could contain anything. It could be an attachment, it could be an image, it could be a video, literally any possible item, and each of these is distinct. Keep in mind that it's possible to get derived values from categorical variables. Like, for example, you can look up London's population and create a new column. You can look up the length of a string that is ordered and use that as an attribute. You could look up the first letter. Or if you have arbitrary text, you can, for example, process the text to see if it has a positive or a negative sentiment. If it is an image, you can extract the names of people whose faces are in that image. These are ways of extracting additional columns from categorical, but the categorical columns in themselves have relatively few operations that you can perform on them directly. Numerical values are what you're probably most familiar with. They could be integers, which could be negative or positive, like -2, -1, 0, 1, 2, or a subset of integers, like whole numbers, which start with 0, 1, 2, and so on, or just natural numbers, which start with 1, 2, 3, and so on. Or you could have fractions or decimals, which can be expressed as real numbers. And that can contain 1.5, 2.7, 3.1, 3.5, or transcendental numbers like e and pi. Composite values combine multiple values in a specific structure. You're probably familiar with some of them, like date or time. A date is a day, a month, and a year combined into one structure. or time is hours, minutes, and seconds combined into one structure. You can also have spatial structures. For example, a point on the map can be characterized based on its latitude and longitude. Or you could have a shape. It could be a line from a certain x and y coordinate to another x and y coordinate. You could have an arc that passes through 2 points with a certain curvature. Or you could have a ring, a polygon that goes from point A to point B to point C to point D and so on. These are examples of spatial structures that are used, for example, in shapefiles to create maps. You could have structured data within a value. For example, a single field can comprise of an entire XML or JSON document, which internally has its own structure. And that structure could be based on a specific schema that is well defined or could be completely arbitrary. Examples of such composite structures are values that you will find when you parse tweets and get JSON objects, arrays of JSON objects, each of which has its own set of fields inside them. This apart, there are several specialized composite structures like IP addresses. These can be, if it's an IPv4, it comprises of 4 integers from 0 to 255, or IPv6 is 6 such integers from 0 to 255. Currencies are just numbers, but specialized with a specific prefix, let's say the US dollar or the British pound. Composite values primarily are collections of values and they are very varied, but they therefore support even more operations than numerical types. And the reason is that you can extract more information, you have more fields to play around with, so it's a superset of everything that's categorical and numerical, plus a whole lot more.